Hello everyone, I'm Frank, and welcome to Frank Puzzles. And this is today's challenging level puzzle. And let's just get straight to it. It's called Reminder, Remember Remainders by Elytron. Pretty interesting. Combination of reminder, remember, remainders. Interesting. Normal Sudoku rule apply. So that means place the digits 1 through 9 once each in every row, column, and box. Oh, we can get a box here eventually. This is a box. Renban lines. Digits on a purple Renban line must be a set of consecutive non-repeating digits in any order. So if this were a 1, you would know there would have to be a 2 and a 3 somewhere along the line, because 1, 2, and 3 is consecutive. Nothing can repeat, so you can't have 1, 2, 1. And obviously you can't have like 1, 2, 4 because that's not consecutive. So that's Renban. Modular lines. Each sequence of 3 successive digits along teal lines, which are the other non-pink lines, must contain one of each residue modulo 3. So, which are 147, which is 1 modulo 3, 258, which is 2 modulo 3, and 369, which is 0 modulo 3. And if you look at it from the keyboard, like if you have a number pad on your keyboard, you can see it divide. You can divide it up by columns. So you see 147 on the left side, you have 258 in the middle, and you have 369 on the right side. So that's how you can divide it up by modulo numbers. And you have to, for every sequence of 3, it must contain one each of those sets. Arrows. Digits along an arrow must sum to the digit in the attached circle. So that means these 2 digits must sum up to this one. This digit must sum up to this one. These 3 digits must sum up to this one. An example of this would be, say this was 1, 2, and, oops, not 0. 1, 2, and 4. This would have to be 7 because the digits on the arrow sum up to the digit in the circle. Little killers. Digits along the indicated diagonal add up to the number provided and may repeat if allowed by other rules. So basically, these 5 digits have to add up to 32. These 5 digits have to add up to 27. These 5 digits must add up to 22. These 5 must add up to 17, etc., etc. These 7 must add up to 37. And these 7 must add up to 27. So those 7 must add up to 27. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. So one thing we know is this must contain... Actually, that doesn't help. It's modulo, right? Okay, I was thinking that this could help something, but it's not. Never mind. This has to add up to 17, and it has a Renban on it. So that eliminates already 789, 678, and 567. 456 is still possible. So you could have 456, 345, 234, or 123. So this is 1 through 6 here. And we don't have a number specifically. So if it's 456, obviously this is 1 and 1. But that doesn't have any other difference, I think. I think it could be 1 through 9 in either of these two cells. This is 22 along this line. And in addition, we know this one is equal to the sum of these two numbers, which is the same as the sum as this one. So these two are the same, first of all, and these two sum to this number. So this is equal to 3 times this number. Therefore, this must be 1 modulo 3, right? Because if you have 3 this is 0 modulo 3, because it's 3x. If you add something to it, it must maintain the modularity. So therefore, this modularity has to be 1 modulo 3. So this is 1, 4, or 7. Now, in addition, this is 3, right? This is, even if this is 1, 2, 3, or if it's 2, 3, 4, 3, 4, 5, 4, 5, 6, it's equal to a 3x number, right? So it has to be 3 times 2, or 3 times 3, or 3 times 4, or 3 times 5. Therefore, this is 0 modulo 3 for these three numbers. And we know this is a 1 modulo 3. Therefore, to add up to 17, which is a 2 modulo 3, you need another 1 modulo 3. So this has to be 147 also. And since we know in modular lines, you have to have one of each set, these can't be 147. So therefore, for this set of 3, where's the 147? It has to be here. So this is 147 also. This is 258 or 369, but we're not sure which. Now, the interesting thing is, if you have one of each modulo on a line, that adds up to 0. You have 0, you have 1 mod 3, and 2 mod 3. If you add those all up, that adds up to 0 mod 3, no matter what. So these three add up to 0 mod 3. We have 1, that's 147. So how do you get to something that adds up to 32, which is 2 mod 3? You need another 147. So this is also 147, right? Because you need a 1 modulo 3, a 1 modulo 3, and a 1 modulo 3 to add up to 0. And then you have add a 0 modulo 3 and a 2 modulo 3 to come up with a 2 modulo 3. So that works there. Okay, along this, we don't know. We do know this set is the same as this one. We also know this set is the same as this one. We know this is essentially from what we said earlier, right? If you have 3 digits on a Renban line, it must be 0. It must add up to a sum that's 0 mod 3. If you have 3 digits that are on a modular line, you must also add up to 0 mod 3. We know this is 1. And this is not 1. These two are the exact same digit. Okay. So this adds up to 1. This is a 1 mod 3. 27 is a 0 mod 3. So the rest of the diagonal must add up to a 2 mod 3. What does that mean? That means the extra digit that's not 3 in a row. Well, okay, obviously there's 3 in a row both ways. There has to be two 2 mod 3s on this line. So it's either 2, 3, 4, 5, or it's 5, 6, 7, 8. It can't be 5, 6, 7, 8, can it? It could be 5. It can't be 2, 3, 4, 5. Cannot be 2, 3, 4, 5 because, right. It cannot be 2, 3, 4, 5 because that only adds up to 14. So it must be 5, 6, 7, 8, which adds up to 26. Therefore, this has to be 1. So this can't be 1. This can't be 1. So this can no longer be 4, 5, 6 allowed. So this can't be 6. So therefore, the 3 is on this line somewhere. This is 5, 6, 7, 8. It can't be 8 because if it were 8, then this is minimum 8 and 1. So therefore, this is 27. It can't be 7 because of the same problem. Well, yeah, this can't be 1 either. So this is 4 or 7. Therefore, this must be... So this is 4 or 7, which means this must be 5 or 6, because it's 5 or 6 times 3. Right? If it's 7, then this has to be 5. But the problem is then you would need a number that's less than 5 on the arrow. So this can't be 5. So therefore, this is 6. This is 6, which makes this 4. So this adds up to 6, which means this is 5 and 1. So 5 is no longer on the rem band, or can't be on the rem band because it doesn't repeat. These can't be 6, therefore this must be the 6 on the rem band. So this is 5, 1, 6, 6, 4. This can't be 4 anymore. That means these add up to 13. Still works. 7, 8, 7, 8. This is 1, and this is 6. So this is 0 mod 3. This is 0 mod 3. We know this is 1 or this is 2 or 0 mod 3. It cannot well, this could be 6, I guess. 7 is somewhere here. Because that's the only 1 mod 3 that's available now in column 5, and it has to have one of them here. This can't be 1, 4, or 7. So it's 2, 5. Okay. This can't be 6. This must add up to with 3 digits. So 7, 8, or it's 7, 8, or 9. Well, I switched it and it didn't switch. 7, 8. It's switching. Oh, I'm pressing the wrong button. My bad. This is 7, 8. Oh my god. I don't know what you're gonna do with me. This is 7, 8, or 9. Okay. If it's 7, this has to be 1. This would be 2, and this is 4. If it's 8, this would still have to be 1. It could be 3 and 4, or this would be 2, and this would be 5. If this is 9, it can't be 1, 2, 6. It has to be 1, 3, 5, or 2, 3, 4. So it could be 1, 3, and 5, or it's 2, 4, 2, 3, 4, and 2, 3. So these are the possibilities. 1 could be here. So it could be 1, 2, 3. This can be at most 6. So this is 6 at most. It can't be 1 or 4. So this is 2, 3, or 5. If this is 6, it needs a 5. And where can it? Can't have a 5 here. Can't have a 5 here anymore, right? If this is 5, this would have to be 1 and 3, but that can't be 1, that can't be 1. So therefore, this can't be 6. So we know there's a 3 somewhere on this rand band also. So this is also 2, 3, or 4. It can't be 1, 5, or 6. Okay, so 3 is somewhere on this rand band. So this is at, okay, what's this at least? 1, 2, and 3. If this is 1, this would be 2, 3, or 2, 3. And it would have to be 3 and 5. So if this is 1, this would have to be 3, 5, which would make this 3 and this 2. So let's just, yeah, do that for now. Let's see, show. So if this is 1, 2, 3. Oh, okay, that's the only one possible for that one. This would have to be 3, and this would be 5. Because it can't be 1, 2, 6, because the 6 is there. Therefore, this would be 2, and this would be 3. So that's possible. If this is not 1, we have 2, 3, and 4. Right? So this would be 2 or 3. This would be 2, 3, or 4. This would be 2, 3, or 4. So we could have 4, 5. 4, 5, that would have to be 3. So 4, 5, 3. So if this is 4, this has, well, it doesn't have to be 5 or 3. This could be 5. If this is 5, this is 4 and 3. Which would make this 2 and this 3. That works. If this is 2, this would have to be 3. This would be 4. But that's not allowed because the 4, where's the 4 in this set then? It would have to be 2, 3, 4. So first of all, also we know a 3 is here. So 3 is here and a 3 is here, interestingly enough. And it could be the same one. It could be here. So if this is 2, again, this would have to be with 3 and 4 because 1s are not allowed anymore. So this would be 2. This would have to be 3, and this would be 4. But then this also has to be 2, 3, 4, and the 4 cannot be here, cannot be here, and can't be here. So this can never be 2 then, if that's the case. What about if we just tried a 4? That works. What with 5? What about 4 with 3 and 2? If this is 2 and 3 and this is 4, this is 2 and 3 and this is 2 and 3, and that both works too. Right? These are opposites and these are opposites. Yeah, that works. If this is 3, it could be with 4 and 5. If this is 3, it has to be 2, 4, 2, 4. So this is 2, this is 4. So this cannot be 3, 4, 4, 3, 5 possible. It could be 4, 3, 2. But no. Because the 4 can't be here, the 4 can't be here, so this can't be 3. So we know there's a 3 here, and we know there's a 3 here. That's interesting. Huh. Okay. Let's see. We know the 3 is here. We know the 3 is here. So we know 7 has to be here, actually. Oh, shoot. Oh, all my speculation was wrong. Yeah, because we forgot about 7 and 8s. Well, we can try it right now, I guess. So far what we have is here for 9s, right? For this equals 9. We know the 7 has to be here, so this has to be 7, so this can't be 7, so we don't have to test that one anymore. We have to test now 1, 2, and 5. If this is 1, so okay, 2 and 3 are not allowed here. So this is 1 or 4. Right, because for 8s, 1 has to be here. So this can never be 4, so we have a 2, 3 pair here. Anyways, let's continue. Let's see. This could be 4, actually. If this is 4, though, this becomes 2, 3, 2, 3, and this is 2, 3, or 2, 3. It could be 3, 4, 5, also. This would be 2, 3, 2, and 3. What about 8? It could be 1, 2, and 5. Therefore, this is 2 and this is 3. That works. Or 1, 4, and 3. Which means this can't be 3. This would be 3 and that would be 2. So that also works. Okay. So this is 1 or 4. Right. 7 has to be one of those two. So we know this can't be 3 anymore, also because of that reasoning. So this is 3, and this is 3. This can't be 1, 3, 4, or 7, so this is 2, 5, 8, or 9, or 6. Actually, I guess this could be 6. This can't be 7 or 8 because it sees both of these 7 or 8s. And one of them has to be 7 and one of them has to be 8. This also can't be 7 or 8 because it sees the same 2. These 3 can't be 7 or 8 because of the same reasoning. So this is 1, 2, 3, 4, 5, 6, and 9. Obviously, this can't be 1 or 6. This can't be 6. This can't be 5. This is 2, 3, 4, 5, 6, or 9. 2, 3, 4, 5, 6, or 9. So this can't be 6. Okay. This can't be 3 because of this 3. These are 2, 5, 8, and 9 because it can't be 1, 4, 7, it can't be 3, can't be 6. So this is 2, 5, 8, and 9. That's interesting. This can't be 1 because of there. Can this be 1, 2, 3 is a question. If this is 1, 2, 3, these add up to 7, and these must add up to 20, which is possible still. We have 22 already done. This could be 3, 4, and 5. And then this is 7. Sorry, this is 1. It could be 2, 3, 4, and this is 4. And it could be 1, 2, 3, and this is 7. Hmm. Uh, hmm. 3 also has to be here. This can't be 1, 3, 5, or 6. Actually, does 3 have to be here? I don't know if it does. No, it doesn't. 1, 2, and 5 works. Well, but 3 cannot be here. Right, so 1, 5, and 6 can't be here. And also 3, right? Because we know the 3 has to be one of these 2, right? Does it actually? That's the question. With 1, 2, 5, yes, it has to be 1, 2, 3. Yeah. Or it's 1, 4, 3, in which case it has to be 1, 2, 3 also. Yep, so the 3 has to be there. So this is 2, no 3, 4, 7, 8, and 9. This must add up to 31. And we know... Can it be with 4 ever? If you have 4, these 3 would have to add up to 27. And you can't have 999. So no, this cannot be 4. Therefore, this has to be 7. Right? If this is 4, these add up to 5. Therefore, these 3 add up to 27, and the only possibility would be 9, 9, and 9, but that can't be 9. Therefore, 4 does not work. Therefore, this is 7, which makes that an 8, which makes this a 7. So this cannot be 8. This is 7. So this is 7. So 7's one of these 3. This adds up to 8, which means this adds up to 24. Oh, and also, yeah, you can't have, yeah, it has to be in modularity, right? So it has to be 8 and 9 in some reason. Yeah, so this is 7. I think this has to be 8 and 9. So that's 24. And then these have to add up to 8, so therefore this is 7. So this is 7. Yeah. So this has to be 7. This is 8 or 9, and this is 8 or 9. So we have an 8, 9, 8, 9 pair in row 6. The rest of the row cannot contain an 8 or a 9, so that can't be 8 or 9. This is 4 and 7 now, which is 11, so this must be 1, 2, and 3. This can't be 7 anymore, so one of these two is 7. This is 7 and 1, which is 8, 8. Hmm. So this can't be 7. This can't be 7 because of this 7. These can't be 7 because of the arrow clue. This can't be 7 because of the red band, whereas the 7, it has to be here on row 6. So this can't be 7. This can't be 1, again, so one of the ones is here. This can't be 7 anymore. Therefore, this is the 7. Eight and 9, 8 and 9, so this is 1, no 1. This is 1, 2, 3, 4, 5, but we know there's a, we don't know there's a 3 here, so this could be 1, 2, 3, 4, 5. It could be 1, 3, 5, 1, 2, 5, 1, 3, 4, or 2, 3, 4. So we don't know what these are. Um, okay, what is this then? So this is 8 or 9. That's 2 modulo or 3 modulo. Uh, hmm. It's still pretty diverse. Okay. So we have the 27, this one set. We have the 17, 22 set. We have the 17 set. We have the 32 set. Now we need to figure out the 27 and the 37. So this is 2, 3, 5, 6, 8, or 9. So 3 is either here or here. It has to be, right? Because you have either 1, 2, 3, 2, 3, 4, or 3, 4, 5. So this one cannot be 3. We already knew that also because this is 3. Um, hmm. 7 has to be one of these 3. I don't know if that helps any right now. 7 is one of these 2. 7 has to be one of these 2. 7 can be one of those 5. 6 has to be one of these 3. Has to be one of these 3. That's all we really have. Um, hmm. Let's see. Oh, we have these, right? Well, yeah, we have these. So this is 1 modulo 3. This is 1 modulo 3. This is 0 modulo 3. Therefore, these two must add up to a 1 modulo 3. Is that right? We have 1 modulo 3 plus 0 modulo 3 plus 1 modulo 3, and it has to go to 0. So that's 2 modulo 3 right now, which means we need 1. So these add up to 1 modulo 3. These add up to 1 modulo 3. This is 0 modulo 3. This is 0 modulo 3. This must also be 0 modulo 3 to maintain 37. So this must be 9, and this must be 8, which makes this an 8, which makes this a 1. So therefore, this is 2 and 3 with it. And it's either 2, 5, or it's 3, 4. So this is 3 or 5. This can't be 3 anymore. Therefore, doesn't this have to be 3? If it's 3, say it's 1, 2, 3, then this becomes 4, 3, which doesn't work. So this can't be 2. This has to be 3. So this is 3, this is 2. This can't be 2. This has to be 3, though, right? No, it doesn't. Oh. Okay, we made a mistake in these. Well, it didn't really affect anything materially, so this is fine, I guess. But, yeah. So this can't be 1. This can't be 1. So this is 2 or 3. This is 2 or 3, which means 2 or 3 cannot be in the rest of the box. So therefore we have 8, 1, 4, 5, and 6 as possibilities. And this can't be 8, so 8's one of these two. This can't be 8. So one of these it cannot be 2. One of these has to be 5 then. So this can't be 5. This is 6, 3, 6, 9, and one of these is 8. This can't be 5. Therefore, this is 6 and 9, which means this has to be 5. So this is 5 and this is 2, which makes this 3 and 4, which means this can't be 3, so this is 2, which means neither of those are 2. So this is 9. This is 1, 2, 3. So then this is 14. So these two must add up to 13. So it's 4 through 9. Can't be 8 here. This is also 4 through 9. Since this can't be 8, this can't be 5, because they must add up to 13. This can't be 6, so therefore this can't be 7. So this is not 7. Therefore, this is 7. Therefore, we know the 7 has to be one of those two. This can't be 7 because of that. Therefore, this can't be 6. This cannot be 4 because it's 3 and 4. This can't be 1. This can't be 1. Therefore, the 1 has to be one of those two. This can't be 5. So 5's one of those two. This can't be 5 anymore. So these can't be 2. We have 4, 8, and 9. Where's 3? The 3 has to be one of these two. Where is 2 in columns? Well, no, it could be here. Never mind. This can't be 7. One of those two is 7. 2 is 7. 2 has to be one of these two, but we don't know which. 4, 5 is here. Okay, so never mind. We have 4, 6, 9, and what's the other one? 2, 3. Yeah. So 4, 6, and 9? Is that right? Yes. So this is 4 and 9, and that could be 3, and that could be 2. This could be 4, 6, or 9, and that could be 3, and that could be 2. So either this is 4 or this is 1, because it cannot be 7 in any of them. This can't be 2 or 5 or 8. So this is not... This can't be 2, 5, or 8. So this has to be 8. Right, because of modularity. There's no 2 mod 3 anywhere on that line except for here. So this is 8. Right now, what does it add up to? So this can't be 8, which means this can't be 5. So this is 4 or 9, this is 4 or 9. Okay. Interesting. If this is 1, this is at most 9. So this would be 10 at most. If this is 6, this would have to be 4. So that's also 10 at most. So this is 10 at most. What happens if it's 10? If it's 10, we have 18, 27, 33. Okay, that seems okay. Which means this adds up to 4, so it's either 2 and 2, which it can't be, or 1 and 3, which it could be. Yeah, I don't know if that helps us. This can't be 2. So this cannot be 2, 5, or 8. It can't be 7 or 8. Oh, this is 7, so this can never be 4. Right? Because it would be the same modulo in there. So therefore this is 9, which makes this 4. So this is 1 or 7. It has to be 1. Because of the same modularity. This is 9, so this is 3 or 6. So right now, this adds up to 15. This is 24. So we have 13 for the other 3. So if this is 4 and 6, this would have to be 3. That works. If it's 1, it could be with a lot of things. But it can never be 3, I don't think, right? If it's 1 and 3, so say this was 3, this would have to be 1 by the modular lines. This is 15 plus 3 plus 1 is 19 plus 9 is 28. This can be at most 34, so this can never be 3, which means we know this is 3 then, because there's no other place for the 3. So this could be 4, 6, 9, that works. 5 is one of these. So we got the 32. So it could be 9, 1, and that's 3. It could be 4, 6, and that's 3. It could be 1, 6, and this is 6. And that's also possible. This has to be 2 or 5 because of the modularity of the lines. We don't know what that modular line is. This can't be 7 anymore. So one of these 2 is 7, but that doesn't help us so much. This can't be 6, so this becomes 2, 3, 5, 8, or 9. This can't be 5, obviously. Let me double check. This is 8, 10, 11, 27. Yep. This is 24 plus 7 is 31, 32. 5, 6, 7, 8, which adds up to 26, plus 1 is 27. 7, 1, 2, 3. 1. Okay, where is the 1 in row 2? The 1 can't be here because of this 1. Can't be here because of the little killer clue. Can't be here because of this 1. Could be here. Cannot be any of these 3. Now, why is that? We know these 2 are different digits, so it's 1 and 3. So therefore, all 3 of these spaces sees both of these cells. Therefore, it cannot contain a 1 or a 3. Therefore, in row 2, the only place for 1 has to be here. So this is 1. This is 3. This can't be 3. This is 4, which means this can't be 4. This is 3, which forces this to be 6. Okay, so now that actually tells us a lot. That means this can no longer add up to 10. Because we have 15. This is 15. That's 30. This must add up to 7. Right? 15 plus 15 is 30. 37 minus 30 is 7. So therefore, this can only be 1 and 6. So this is 5. This can't be 5 or 6. This is 8. This can't be 8 here. So therefore, this is 8. This can't be 1 or 8. This is 6, which makes this a 9. This makes this a 3 and makes this a 6. So this is 2 or 4. This is also 2 or 4. These can't be 8 anymore. This can't be 6. This is 2 or 5 still. This is a 5, so this can't be 2. It could be 4. It can't be 1, 4, 7, so this has to be 3, 6, or 9, so therefore this is 9. Which means this can't be 9. These can't be 9, this can't be 9. Where's the 9 in box 8? It has to be here. So the 9 has to be one of those 3. This can't be 1. This can't be 3. This can't be 8. So I think we have all the little killer clues done, right? Yeah. So they're all added up. So the little killer clues do not help now. This is 2, 4, 2, 4. 7 does have to be here. Okay, so we have, what, 2, 6, and 7? This can't be 6. This can't be 6. The only place for 6 is here now in column 7, and therefore this is 7. Therefore this is 2. So neither of these could be 2. We have 1, 3, 4, and 5 here, so this can't be 6. This is 1, 3, 4, 5. This could be 3, 4, 5 because it can't be 1. This can't be 5 or 4. This is 1, 3, 4, 5. This can't be 2, so this is 5, which makes this not 5. So this is 1, 3, and 4. This can't be 3. This can't be 6. Okay. These can't be 5 anymore. Because this has to be 5 for the modular line. If this is 4, this would be 3. If this is not 4, this is 3 or 9, it must be with 1. That doesn't tell us anything, though. This is done too. Modular. Okay, so this is 2, 5, and 7, right? So this is 2 or 5. This is 2, 5, 7. This is 2, 5, 7. So we can remove those marks. This is 3, 4, 5. This is 3, 4, 5. This can't be 3 here. So this is 4, 5, 2 or 4. We have this can't be 1, therefore the 1 must be here. We also have 2, 5, and 7. So this is 1, 2, 5, 7. This is 2, 5, or 7. This can't be 7 anymore, so this must be the 7 here. Since this is 7, this can't be 7. Therefore, this must be the 7. These can't be 7 anymore. One's here. We have a 4, 9, 4, 9 pair in column 3. So now the other numbers have to be 5 and 8. That's fine. 2 has to be one of these two. This can't be 5, and this can't be 2. 8 has to be one of these two, but we don't know which. 8 can't be here. 8 could be any of these three. Okay. This can't be 6, so therefore this has to be the 6. Where is the 2 now? The 2 cannot be in the 6th spot, so now it has to be here. So this is 2. Where's 8? 8 can't be here or here, so this must be 8, which makes this a 5. So this can't be 5 anymore. This can't be 2, so this is a 3 or 9, which means it's 0 mod 3, which means this has to be a 2 mod 3. So this is 2 or 8. We have... This is 2, 3, 8, and 9. So this also has to be 3 and 9. So this can't be 3 or 9, therefore this is 4, which makes that a 3 because of the modulo line. Can't be 1, so this is 9. This has to be 1, this is 5. So this can't be 9, this is 4. This can't be 4. We should have had that waited in the beginning. Anyways, this is 2 or 8. This can't be 1, this can't be 1, so this is 4. This makes this 5, and this 3, which makes that 4. This is 1. This is 3. So this can't be 1, therefore this is 5, which forces that to be 2, which forces that to be 5. This is 4. This is 2. This can't be 3, so this is 9. This is 3. This has to be 1. So this is what? 2 and 9. This can't be 9, so this is not 6. It's 2. This is 9, which makes this 8 and 2. So that's 8, and that must be 4. And that's a solution. Pretty cool, pretty cool. I like the modularity with the little killer clues because therefore that allowed a lot of puzzle solving without having certainty in certain spots. It was very cool, very cool. I like the use of the reminders. I guess, sorry, the remainders being reminded about that. Anyways, I hope you had a good time too, and I'll see you next time on Frank Puzzles. Take care.